Good morning, students. Class 12th, chapter number 6, applications of derivatives, test solution of chapter 6. So I'm going to discuss all the questions given in the test. As you can see, here is the first question for test, which says the radius of the circle is increasing at the rate of 0.7 centimeter per second. That means the rate of change of radius with respect to time is equal to 0.7 centimeter per second. Now, what is the rate of increase of its circumference? So suppose, let us denote circumference with c. So we have to calculate d by dt of c. We know d by dt of the circumference value is 2 pi r. Clear? Now we can write it as 2 pi constant. Taking it outside, we have dr by dt. Putting the value of dr by dt, which is 0.7 centimeter per second, we get the answer as 1.4 pi centimeter per second. So this is what rate of change of circumference. Clear? Let us discuss question number 2. In question number 2, you were given a function f of x. It is sine of 2x plus 5. This is the function. We have to find the maximum and minimum values of it. So we know any angle of sine we have, the maximum and minimum values are -1 to 1. Clear? Now adding 5 on all the sides, we have -1 plus 5 less than equal to sine of 2x plus 5 less than equal to 1 plus 5. So we have 4 less than equal to sine of 2x plus 5 less than equal to 6. So we see the minimum value of this function is 4 and the maximum value of the function sine 2x plus 5 is 6. Clear? This is how you will be calculating maximum and minimum values. Let us discuss question number 3. In question number 3, we have been given a curve. Curve is 6 pi equals x cube plus 2. It is said in the question, a particle moves along this curve. We have to find the points on the curve at which y coordinate is changing 8 times as fast as the x coordinate. That means dy by dt is equal to rate of change of y coordinate is 8 times as fast as x coordinate change. That means dy by dt is equal to 8 times dx by dt. Now differentiate this function with respect to y. We get 6 dy by dt equals 3x square dx by dt plus of 2, the differentiation will be 0 being a constant number. Now 6 multiplied with dy by dt can be written as 8 dx by dt equals 3x square dx by dt. Dx by dt and dx by dt will get cancelled. We get x square as equal to 6 multiplied with 8 divided by 3. So we get it as 16. Now x square is 16. That means x is equal to plus minus 4. We have two values of x. Using these values of x, we can find out the y coordinate by putting the value of x here. So we have 6y equals, if we put 4, let us write x equals 4. So at x equals 4, we will have 4 cube as 64 plus 2. So we have 6y is equal to 66. So y is equal to 11. So one of the coordinate is 4, 11. Let us find at x equals -4. 6y will be equal to minus 64 plus 2. So we get 6y as equal to minus of 62. Solving it, we get minus 62 divided by 6, which is minus 31 divided by 3. Hence, the another point is -4, minus 31 divided by 3. Clear? And we had to calculate the points only. So these are the 2 points at which the rate of change of y coordinate is 8 times as fast as the x coordinate. Clear? Let us discuss question number 4. As we can see in the question number 4, it is said water is running out of a conical funnel at the rate of 5 cubic centimeter per second. That means this is the volume. So we have been given dv by dt as equal to 5 cubic centimeter per second. Now just to see, water is running out. That means the rate is decreasing. It's going down. Clear? So I am using a minus sign in front of it, which shows that the water level goes down with time. Now, if the radius of the base of the funnel, the radius is given as 10 centimeter and the altitude, that means height, is given as 20 centimeter. So we have to find the rate at which water level is dropping. So dropping level will be dH by dt when it is 5 centimeter from the top. That means the water level is 5 centimeter from the top. So we have to calculate this. Clear? At what? Earlier height is 20 centimeter, but we have to calculate the change or the drop in water level when it is 5 centimeters from the top. That means height will become 20 minus 5. This is the level of water. It is 15 centimeter now. Clear? So we have to calculate dH by dt at h equal to 15 centimeter. Clear? Let us now differentiate this. What is the volume of the conical funnel? 1 upon 3 pi r square h. So we will write d by dt of 1 upon 3 pi r square h equals minus 5. Also, we have the function in r and h. We can convert it only 1 by, see, if we take the ratio of r and h, we get 10 upon 20. That implies r upon h is equal to 1 upon 2. Also, we can say that r is equal to half of height. Clear? So just to see now, putting this value here, 1 upon 3 pi being a constant, taking out, instead of r, I am putting 1 by 2h. So what will be r square? 1 upon 4 h square into h is equal to minus 5. Clear? And we have d by dt of this complete function. Is this clear? What we have done? Instead of r square, I have placed 1 upon 4 h square and h. Clear? Now 1 upon 3 pi into 1 upon 4 into, now h cube, this will become h square into h is h cube. Differentiation of it will be 3h square dh by dt equals minus 5. Clear? Now 3 and 3 will get cancelled up. So we have h square upon, it will be 4 pi dh by dt equals minus 5. So what we will have at the end? We will have dh by dt equals minus 5 multiplied with 4 pi divided by h square. What is the value of h here? 15. So 15 square is 225. So cancelling it now, we can have 5 ones are 5 fours are 20, pi 5s are 25. So we have minus 4 pi upon 40 pi centimeter per second. So the negative sign shows the water level is going down. So the rate of change is 4 pi upon 45 centimeter per second. Clear? Because it is a conical funnel, so it is in the shape of cone. It is like this. This is suppose the top of it and the funnel is like this. Here is a hole. Clear? Let us go to another question. Question number 5. In question number 5, I gave you two options. You had to attempt either of the questions, so we'll discuss both of them. In first of the part, we have to find a point on the curve y equals x minus 3 whole square, where the tangent is parallel to the line having these points. That means the line is passing through this point and that line is parallel to the tangent. That means if two lines are parallel, their slopes are equal. Let us find the slope of both. So slope of tangent from here is dy by dx equals 2 into x minus 3. And using these 2 points, if I find the slope, slope will be calculated as y2 minus y1, which is 0 minus 1 divided by 3 minus 4. So it is 1. Now we will put 2 of x minus 3 as equal to 1. We get x minus 3 as equal to 1 upon 2 and x is equal to 1 upon 2 plus 3, which is 7 upon 2. Now if we put 7 upon 2 in the equation of curve, we can get the value of y, which is 7 upon 2 minus 3 divided by 2. So we get the answer as 1 upon 4. So the point is 7 upon 2 comma 1 upon 4. This is the point on this curve where the tangent will be parallel to the line that joins these two lines, these 2 points. Clear? In the second part, if I discuss, in the second part, what is given? That we have to differentiate this function because we have to find whether this function is increasing or decreasing, or we have to tell in which interval it will be increasing and which interval it will be decreasing. So just to see, if I differentiate it, we can get 3x square minus 24x plus 36. Okay, taking 3 common, we have x square minus 8x plus 12. Now, making the factors, we get two factors by writing 8x as minus 6x minus 2x plus 12. So, we have 3x, x minus 6, then minus 2, x minus 6. So, you see we have two factors, x minus 2 and x minus 6. So, if I plot this on number line, it is minus infinity, infinity, and then we have 2 and 6. So we have three intervals, these three intervals. First is minus infinity to 2, then 2 to 6, and then 6 to infinity. So let us check minus infinity to minus 2. If you put it as equal to 0, we got two critical points, right? So this is our dy by dx, or I say the derivative. So in this we have to put and check whether it is greater than 0 or less than 0. If you put any value between minus infinity, comma 2, suppose we put as 1, we get the answer as positive. So in this case it is increasing. From 2 to 6 if you place any value, we get it as negative, which shows it is decreasing, right? And 6 to infinity you place any value, you will find the answer as positive, which shows it is increasing. So it is increasing in two intervals and decreasing in which interval? 2, 6. Clear? This is what you had to do in question number 5. Let us go to question number 6, which was the last question and also 6-mark question of the test. We have to show the height of the cylinder whose volume is maximum. So let me write the volume first. It is pi r square h. Now, which can be inscribed in a sphere of radius r. So we have to make one sphere and we have to inscribe in it a cylinder. So let us do that. So this is a rough diagram where a sphere is there and the cylinder is inscribed in it. Height of the cylinder is represented by h. Capital R shows the radius of sphere and small r shows the radius of the cylindrical. Okay, now volume is pi r square h, which we have to show as maximum. That means the second order derivative should come as negative. That means less than 0. Also we have to prove the height of the cylinder. Think carefully, height of the cylinder, that means h, that can be inscribed in a sphere of radius r is 2r divided by square root of 3. So this is also one of the things that we have to prove. Clear? So what we will do is, just to see, this is the volume. From this, can I use Pythagoras theorem in it? Yes, definitely. So we can write 2r whole square is equal to 2 small r whole square plus h square. We have used Pythagoras theorem in the triangle. If I name it as, suppose, ABC. Clear? Solve it. We get 4r square is equal to 4r square plus h square. Now pi r square h, and we are getting h square plus 4r square as equal to 2r square. So let us calculate the value of r square. It is 4r square. So 4r square minus h square divided by 4. Let us put it here. Volume will become pi. Instead of r square we are putting 1 upon 4. 4r square minus h square multiplied with h. Let us multiply this h inside. We get pi upon 4. 4 r square h minus h cube. Then we will differentiate it. So we'll differentiate it with respect to h, because the volume of the cylinder depends on small r, not capital R. Capital R is the radius of sphere. So that is a constant for us here. So let us just find out dv by dh. What we get? Pi upon 4 as it is. 4r square as it is, being a constant, differentiation of h is 1 minus 3h square. Putting it as equal to 0, we get 4r square equal to 3h square, and we get h square as equal to 4 upon 3r square. Okay, if we take the square root, we get h is equal to 2r divided by square root of 3. So we have got this as our critical point. Now let us differentiate it again. We get d square v by dh square, that comes out to be pi by 4 as it is. Differentiation of 4r square is 0 minus 6h, which comes out to be negative, which is less than 0 at h, right? Because h is positive here, 2r upon root 3. If we put that, we'll get a negative value. So we have proved that the volume is maximum when the height is equal to 2 upon root 3 times the radius of the sphere. Clear? This is what we had to prove in this. So this is all about your test, and today you're going to read the summary of the chapter matrices from NCERT because it is a very easy and interesting chapter. And to subscribe the channel, add Quark.